My name is Svetlin Nakov. I come from Sofia. I'm a blockchain engineer and technical trainer, entrepreneur, and many other things together. And I want first to ask you, how many of you are technical people who read code, who write code? Most of you. How many of you are not technical people? Not much. Okay. I will have something for both of you, both of these groups. I will talk today about Multisignature wallet, first from the business perspective and then from the technical perspective, how to implement this. I will focus on public blockchains, such as Bitcoin and Ethereum, and will demonstrate code examples with Ethereum because I believe that Ethereum is the programmable blockchain which is designed for developers, and Bitcoin is designed to be a cryptocurrency. Okay, so the happy news now are that the cryptocurrency aspect of Ethereum is going somewhere because of the bear market, and today we enjoy about inexpensive transactions, and some people are unhappy because they have invested in the past. But a few words about me. I'm a software engineer, very distinguished, famous, but mostly in Bulgaria, where I built 3 successful training academies. First, I started with small ones, like the National Academy for Software Development. A month later, my company was acquired by Telerik, which were sold a few years ago for 360 millions. And finally, I found the the software university, where we teach 100,000 students, and it's really big. It's bigger than the technical university in Sofia, for example. But it's an accredited program. It's something like Code Camp, but it's better because we study for 2 years, including data structures, including functional object-oriented programming, and many other things. My blockchain background is something like less than 2 years. I was advisor in this project Walktrip, which works today. I just also booked my stay in Berlin through it. It's about decentralized hotel booking platform, just like Booking.com, and people 3 months after the ICO, which raised something like 10 millions, it was small ICO, they were able to book their hotels on the blockchain with a decentralized, in partially decentralized way, to be honest, because still the blockchain is not ready for real decentralized application. This is the true story. For example, how to maintain a booking platform with 400,000 hotels. Just the photos for these hotels are something like 30 gigabytes. It's a challenge. Yeah, we can put them in IPFS, and this is what we do. But there is no practical, stable implementation as database on the chain. But let's talk about other things. I also were head of this educational project. It's about training blockchain developers. It raised some millions, and now it runs blockchain code camps in many locations in the world. We started from Sofia, of course, and we had many others. I'm an advisor in many crypto startups, but recently I work on other projects. In the last month, I'm writing this free book about cryptography because I had a lot of experience with encryption, with public key crypto systems like elliptic curves cryptography and many other things, and I constantly give talks at many locations in the world about these topics. It's completely free, and it's really, really good about, for example, just some pieces of the code with code examples. But the real reason to be here is to share my experience and my recommendation, my thoughts about the so-called multi-signature wallets. It's a concept from one perspective, and it's a code from other perspective, and it's a technology as third perspective. So I'll start with the problems and why do we need multi-signature wallets. I will talk about the concepts and how they work conceptually, And later I will explain how they work technically in Bitcoin without deep technical details, of course, because we should program on Bitcoin script, and it's a little bit unpleasant because they even don't have a programming language. It's something like programming by putting some binary data and trying to compile, to achieve compilable code. In Ethereum, things are different because people use Solidity, and Solidity is one of the best invented languages one of the easiest to use languages for the blockchain, and it's really pleasant to have it. It has problems, of course. For example, by design, it's not so scalable like we want. Some languages are more scalable, but in Ethereum, we write multi-signature wallets just as a simple smart contract. And I will demonstrate a DApp from Gnosis, which is one of the biggest successful ICO projects. It's market prediction platform based on cryptocurrency. And I will demonstrate this Ethereum code in action. I'm not the author of this code, and I recommend that you should also not be an author of multi-signature wallets implementation, because it's about money and it's about security. And even leaders in the industry like Parity had problems in their multi-signature wallets and were hacked. One Bulgarian startup called Eternity, which is something that less than 100 millions, it's not from the biggest player, lost 30% of their funds due to a bug in a multi-signature wallet implemented by Parity. You know, Parity are maybe the largest implementer of the Ethereum protocol. So they have a bug. So it's not a good idea to write such code yourself unless you are very, very, very big professional in Solidity and in smart contract security. I will show you a lot of examples, but let's first start with the scenario. The scenario is about managing significant amounts of crypto assets. In the banks, some bank can offer this service to have multiple signatures in order to send payments, for example, but in the crypto world, it's done through crypto. For example, the ICO projects, which were modern 1 year ago. I'm sorry that today ICOs are over, but the next big thing is coming. It's called STO, Security Token Offers, which binds crypto tokens to real stock, to real portions of certain company. But let's come back here. So the scenario is about managing some significant amount of crypto assets, but we have a lot of problems. For example, what will happen if a key is lost? You know, in the cryptocurrency world, you have a private key or a wallet or mnemonics, which are used to derive your private key and to make it more rememberable in a way that you can just print these mnemonic words and keep them in a safe. But it might happen that you lose the key. So on the blockchain, your money are locked forever. There is no solution about this. Yes, there are solutions with intermediate organizations, just like banks. If you don't want to have a suitcase full of money, you usually put your suitcase full of money in the bank, in a form of account, and you trust the bank. But if the banks are fraudsters, your money will be lost. The same is on the blockchain. There are intermediate organizations who want to keep your private key, and if you come with your ID, they will recover it. Something like this. But the key could be stolen. This is the bigger issue because typically the funds on the blockchain are hard to trace. They are not completely anonymous, but there are some ways to keep tracking them. For example, people who hack the exchanges, and this happens often because their exchanges are created not by proven engineers, but just some startups, some people who are trying to do their first exchange in in their life, and if you're hacked, your money will be lost, typically, and nobody will be put in the prison because government cannot track this, and police. Illegal activities, there are lots of illegal activities, sorry about this, and you can maybe become a subject of frauds, and accidents happen with people because we constantly fly with aircraft, so it might happen that a business can stop because of some accident. So many reasons to use a smarter way, just instead of keeping a single private key somewhere. For example, I have seen in my experience many things. The first thing I saw was the following. People created a hardware wallet, Ledger for example, Nano, and they created a mnemonic, and they printed it on a sheet of paper. They split the sheet of paper, and one half of it was taken by one co-founder, and the other co-founder was assigned to keep the other piece. It's not a good idea, because this means that if either one of them something happens, or with his safe, or with his home, or it might be fire accident, or the money will be lost. So there are lots of examples about this. So how to do this in a better way? If you want to split a private key into pieces, there is a mathematical concept behind this which can do the job. It's based on Lagrange interpolation polynomial, where if the polynomial is of power 5, for example, if you have some of the keys, you can recover by the others. It's a max. It's the so-called chamber secret sharing scheme, and you can define some split schemes. For example, 2 out of 3. I will demonstrate this because it's easier to demonstrate it instead of just explaining. So this is this one. So I want to generate a split wallet where I have 4 shares, and I need 2 of them in order to recover. So, for example, we have a crypto startup, and we have 4 co-founders, and we want to split the key between them. For example, Peter takes this key and keeps it in a safe. Maria takes this key. It's not key, it's a just piece of key. Okay, so if Peter and Maria come together, or for example, Stefan comes and puts his piece, these 2 pieces, something didn't copy correctly, but these 2 pieces out of 4 can be combined, and this is the private key. But there is a problem here, because at the time they combine it, someone can just take a screenshot, or can just take a photo. Someone now in the web can take a photo of this key, and it's no longer shared, it's there. But this is better than doing something stupid like cutting a piece of paper into 2 equal pieces. There is a better way to do this. But this is not called multi-signature wallet. This is called split private key, where the key is split into 4 shares, and any 2 of them are enough to recover the key. Okay, this is based on the Chamber secret sharing scheme. But my talk will be more about the multi-signature wallets, which are better concept to solve this problem. So it's a kind of, let's say, wallet or tool, or in Bitcoin it's a kind of address published on the chain, which holds assets, some assets. It might be cryptocurrency or tokens, or it might be things protected by a smart contract, which are spendable by n signatures out of m, where n is less than or equal to m. For example, 2 of 3 means at least 3 signatures, at least 2 signatures out of all participants should be enough to execute a transaction or to sign successfully a transactions out of 3 owners. So in wallets we have owners, people who can together manage the assets behind the wallet are called owners. So when we create a multi-signature wallet, we specify these owners. These owners are usually blockchain addresses, because you know that blockchain is partially anonymous. It's about addresses, and there are no identities behind these addresses. There is no even email address. There is no phone number. There is no person. And in cryptography, this problem about the identity is solved by digital certificates. The same could be done with the blockchains. For example, some certification authority can publish a digital certificate and sign it to guarantee that certain address, blockchain asset address, belongs to some person. But this is another story. So, multi-signature wallets have owners, which is a set of addresses, blockchain addresses, and threshold. Thresholds means how many signatures out of these owners are required in order to sign and successfully execute the transaction. For example, if you have 5 owners and we have threshold of 2, this means that 2 people randomly selected from these owners are enough to execute the transaction. Okay, so once the wallet is created, it can be created by some tool. For example, the Bitcoin Core wallet can create for you a multi-sig wallet. Usually, you don't need to be blockchain expert to use this. It's an app, like any other app you use. For example, people are not banking experts or developers when they use their e-banking. It's something like the e-banking app, and I will demonstrate it. It's pretty trivial to use it. So once you have the wallet, you submit a new transaction for multi-signing. Initially, when you create the transaction, it's not signed by anyone. Once you submit it, it's signed by you, by the sender, by the person who created, and this submission can be done by someone belonging to these owners. There are only the owners. One of the owners can submit a new transaction. There is a sign process which is done over the time. For example, I create a payment request, a transaction. I put it on the chain. It can be kept on chain or off chain. Off chain means that it's a text file, and I send this text file by email or by WhatsApp chat to someone else. He signs it, and again, I will demonstrate this. But signing of a transaction either changes the state of existing multi-signature transaction on the chain in the first scenario, or just adds another signature into a text file, which is the text representation of the transaction. And finally, once enough signatures are collected, the transaction can be executed. It typically can be executed by anyone because it's not about security. If I have enough signatures, I can take the transaction and just broadcast it on the blockchain network. And the transaction holds what will happen, who will pay, to whom will pay, or what smart contract operation will be executed. Okay, so let's start first from the Bitcoin scenario. It's the more complex, but it works offline. So you don't need to have internet connection in order to work with Bitcoin multi-signature addresses. They are not called multi-signature wallets in Bitcoin. They are called multi-sig address because they are normal blockchain addresses, and this address, like this one, wow, what happens? Like this one, this is a kind of address, but this address is related to this redeem script. The redeem script in Bitcoin encodes some programming logic which says who can spend this money and how. And there is a multi-signature redeem script which is a kind of assembler code. It's called Bitcoin script code, and I will demonstrate this. So the idea is someone creates a transaction. someone signs these transactions. Once it's signed, it's sent to someone. The person who receives this transaction decodes it to check what's inside, because it looks like this. This is a Bitcoin transaction, encoded in hex in some format. But it holds some some payments which can be signed or not, and which can be signed by multiple people. So I will demonstrate this live. But finally, a person takes the transaction, signs it, and the output of this signing is another transaction, another such hex digits. He sends it by email or by other electronic way, like chat, to someone else, to his colleague. The other owner of the multisig address signs it, and finally, the last person commits it. Let's demonstrate this live. So, first, we go at this online wallet called coinb.in. Coinb is a client-side wallet. If I switch my internet, this will continue working. So, it's client-side. It's just like desktop app, but it's on the web. So, unless this address here is broken, it's considered secure because it's open source and things like that. It's better, of course, to use, instead of these two, to use some hardware wallets. And some hardware wallets have apps which support multi-signature transaction signing. You may know that keeping significant amounts of cryptocurrency on your computer is a bad idea, generally. Why? Because if I go to the toilet now and someone installs a keylogger or some plugin for my browser, he can take my private keys. The same applies with my phone. So it's not a good idea generally to keep in your computer private keys which hold significant things. So the way cryptography solves this is called a smart card. Smart card is a chip-based card which can sign transactions, right? This is what some banks give you. They give you a USB stick, right, you know, and you put this USB stick and sign your bank transactions. In the crypto world, this is called hardware wallet, which has a crypto processor called secure element, and this secure element holds a private key which cannot leave the device. There is no hardware or software or other way for the key to leave the device. If you try to break it, the key will be forgotten. But so the idea is, don't use this tool. This is just to illustrate it. Use hardware tools. But I have a colleague who works in Bitcoin Gold, and the transaction which I will show you comes from him. This is one transaction where they signed the monthly salary payments. So it comes from the real world. But let's first start here. So we have multisig address. We put here the public keys. These are not the blockchain address. These are the public keys of the people who own this multi-signature address. So having this, and this, for example, Peter's key, Mariah's key, and Svetlin's key, and we say 2 out of 3 here, it generates this one and this one. This one is the multi-signature address. This is an address which comes together with this script. This is a normal address where people can just send money, but this redeem script defines the logic used to spend this money. In Bitcoin, this logic is encoded in such scripts. In Ethereum, this logic is encoded in Solidity smart contracts or in smart contracts, because blockchain has limited functionality. So we can decode this script, in fact, and this script is something like, I will copy it, and we'll try to decode it. This is a tool to decode a redeem script. It's this one, assembler, the Bitcoin assembler. This is the number of arguments, which means pushing the stack, this one, and also this one, and this one. No, maybe the first one is the code of the instruction. And finally, these 3 things, combine them and execute the algorithm a code check multi-signature. This is for developers. If you are not developer, or if you are not assembler level developer, it will be hard to understand this because it's about low level programming language, which is stack based, just like the Java virtual machine, for example. Similar but limited. So this is what is behind here. So assume we have this. When I want to create a new transaction, I need to go here. I will put some addresses who, for example, I want to pay someone 5 bitcoins, etc., etc., etc. And when I submit this, it needs some redeem script. See, this redeem script here for the multi-signature. I put it here, and I combine it with some other things, the input. This will be the transaction ID, because Bitcoin is not like a bank account. It works with unspent transaction outputs, UTXO, maybe you know it. It's, money in the Bitcoin are not related to Bitcoin address like many people believe. They are locked into unspent transactions. So they are something like banknote. If you have banknote of 5 Bitcoins, you either spend the entire 5 Bitcoins or you don't spend it. There is no way to partially spend money. To partially spend money, you pay to someone some money and you give the rest of the money back to you. It's 2 payments, but this is how Bitcoin works. So the next thing is when I create a transaction, it looks like this. I can decode these transactions just to see what's inside. I put it in a tool to decode it, and what's inside, it's visible for developers here. It's a transaction, it's related to these Bitcoin addresses, etc., etc. It has hashes, but the inputs here are these transaction hashes. So this encodes a UTXO, unspent money staying received by some transaction. Okay, so what happens next? The person just verifies the transactions. And what's encoded here? This transaction says, I will spend this UTXO, and this UTXO, which are multi-signature addresses, 3 separate multi-signature addresses. That's why in Bitcoin it's more complicated, because if you want to partially spend money, you need to work with multiple inputs. It's more complex, okay? And they are signed by 1 person, and this needs just at least 2 people to sign it in order to be executed. So the person previews this and checks, for example, I will pay Peter this amount and George this amount. These are, for example, the salaries for the monthly payment. Finally, they will sign it with some private key, for example, this. Again, this should be done by hardware, not here, because it's less secure. When you sign this, when you click sign, out from this, okay, you receive this. So this transaction holds 1 signature, and this holds 2 signatures. You can see that there are differences, right? So the input from the multi-signature transaction here is 1 transaction. After signing, you get another version of this transaction with more signatures. Once you have enough signature, you go here, you put the transaction and submit it. Of course, this didn't happen because it's not correct one for this network. In fact, I took this transaction from Bitcoin Gold, which is different network. It's not Bitcoin. Okay, let's talk about Ethereum. In Ethereum, things are more simple. There is a better chance to fully understand what happens here than in the Bitcoin, because Ethereum uses the so-called accounting model, account balance model, which is the same like in the banks. In the banks, you have IBAN and some money at this IBAN. If someone pays you 100, your amount will be increased with 100. It's very simple, like in banks. In Bitcoin, it's totally different. It's not like this. So in Ethereum, smart multi-signature wallets are implemented as normal Solidity smart contracts. Example of such smart contract is this one. This one comes from Gnosis, and it holds hundreds of millions today. So it's better to rely on this logic. I will talk a little bit more what's inside. Instead of writing yourself a multi-sig wallet implementation, because you might be not perfect developer and you may make a mistake. So, just an example of this smart contract, it's used by the Golem, and it currently holds 50 millions on this bear market. And the other example is Aragon. This is the address in Aragon, and it holds something like 30 millions today. Hundreds of thousands of Ethers. And it's actively used. So, what's inside? The most important functionality is here. When you create a wallet, you pass as argument the array of addresses of the owners. For example, you put here Mariah's address, Peter's address, and George's address. And you send here the threshold, for example, 2. Here we have 3 owners, and we need 2 of them, at least, in order to do something. And these owners can be changed later. But in order to be changed, people who can decide should sign it. For example, if I want to add one more owner here, 2 people still should sign this change, right? So people who are, for example, in a company, people who own certain company can take another member in the board, right? And they vote for this. And after they vote for this, the new owner has the same rights like the previous one. This is how it works. So owners can be changed, which is good because companies change. For example, today you work in a certain company and you operate with some money. Tomorrow you change your job and you should be deleted here. This is how it works, okay? The next thing is to submit transaction. To submit transaction, you just put the address, some values and some data. This data can encode many things. For example, it can encode token transfer. On the Ethereum, token transfers are programs which are executed on-chain, and these programs change the state of some smart contract which holds the tokens for certain project, for example, the WOC tokens or Aragon tokens, for certain address. They behave like a bank, and they keep what address, how many tokens it does holds. So the next thing is confirm. I also call it co-signing, which confirms means that certain sender of this transaction can say, please confirm transaction ID 1. In this smart contract, they are numbered from 0, 1, 2, 3, 4, etc. This is not transaction ID, but this is what is written in the code. It's transaction index. It's array index, in fact. Because in Solidity, we don't have lists. We have just arrays. And it's a little ugly. For example, you cannot delete the 3rd element out of 10 elements array. You need to build a new array and copy the elements. Because it's not designed for this. Solidity and blockchain is not a database like the other people share today. It's just programs. They hold programs which have some small state. The state should not be large because it costs a lot, and because if you have large state, it will be replicated to 30,000 machines, because today the Ethereum network holds 30,000 nodes, and all of them have the same copy of all the transactions ever happened on the network. And the final is execute. A transaction can be executed once the signatures are collected. Okay, I will demonstrate this now live using this Gnosis multi-sig wallet, and this will be the most interesting thing today. So, we open this Gnosis wallet.gnosis.pm. This one. It's web-based. this doesn't make it insecure because by design it supports hardware devices. I will start from this. At the settings, you select the network. I will use this Ropsten network, which is the testnet. I will play with free coins, with some test coins, like developer mode. This is the mainnet where coins cost money, real dollars, okay? And it supports different providers. For example, Ledger Wallet, it's a hardware wallet which I personally use to keep my blockchain assets. And it holds its private key on the device, and this private key cannot leave the device. It's proven mathematically, physically, and in many other, and it's certified. Okay, so I can create a wallet. When I create a new wallet, I just say, for example, sample, and I put my account and some other account. For example, I have some accounts here. I will put Nakov here, and it's a good idea to have names. Nakov and Mariah will use this wallet, okay? So I add these people, and currently, who is the person to execute this transaction? He is Nakov. This is MetaMask. MetaMask is kind of wallet, not multi-signature, normal, which can sign transaction. I will use this one instead of hardware wallet because I don't bring with myself, and this is more simple. So I'm Nakov, and I have at my balance this, at this address, okay? So I will deploy the contract. Now I will put 1 giga away as tax, as mining tax, and I will send this transaction. This transaction will be executed by MetaMask, and it will cost some money, and it will create here, the transaction is this one. See, this is my signature, multi-signature wallet, in fact. This is a program, just like in Bitcoin. It's a program, it's a compiled source code, which deploys the wallet contract. It will take some time. You know that transactions are mined by miners, and usually in the Ethereum network, it takes 10 to 15 seconds for the mining to happen. I will refresh. There is no good refresh button here, but it looks like it will take some time to do this. I will use one from my existing wallets, and the other will appear in a few minutes. So I have created previously a wallet in the configuration 2 out of 3. It currently holds this Ethereum amount. It is deployed, this wallet is deployed at this address. Let's see what's inside. On the Ropsten testnet, I have this address, and this address holds a wallet. Wow, it's Etherscan. See, this is not the testnet, this is the mainnet, so it's empty. I will use ropsten.etherscan.io, and we'll put the wallet address. The wallet is this code, right? Okay, we'll look inside. So if we read the contract, we can see that the owners of this wallet are these 3 addresses, right? These 3 people or machines behind these addresses can control this wallet. But to sign a transaction, you need to have at least 2 signatures out of these 3 addresses, okay? So we have, let's go back at this window. So if we go here, these are the owners. It takes some time. Nakov, Mariah, and Peter control this wallet, and 2 of them are enough to take decision about signing or revoking certain transaction. Okay, so I will create a new transaction. So I want to pay to Emma at this address. I want to pay her 0.1710. This is the time. It's easier to debug, in fact. So that will be all. And, amount. Oh, sorry. It's not here. The amount. And I will sign the transaction. Who am I? I should be one of these owners. I'm Nakov currently. This is the account where I operate. Typically, you have only one account of your computer, or sometimes you have multiple, but I will use a single laptop here and we'll just switch accounts, okay? So I put some gas price and send the transaction. So this transaction says, please create an unconfirmed multi-signature transaction which will stay on-chain, and this transaction will be put in an unconfirmed state. We can see this transaction here. Let's see what happens here. If I refresh the contract, first I need to check whether the transaction is here. See, this is my last transaction, which says, please create, submit transaction to this address, and the amount is encoded here. This is 7, yes. Okay, so what's also here, if I read the contract, I will see first how many transactions are there. There are 6. So the last number is transaction number 5. It starts from 0. So it has one confirmation. This is the same thing shown here, right? See, this is the destination, the thing, only they don't have date, which is bad here in the UI. It's good to have accountants wants a date of the event. So Nakov has already signed. I'm, as an author of this transaction, I have already created this signature by confirming at the previous. So I switch my account. I switch my account to some other contract owner, Mariah. Now I'm Mariah. This will change. See, it's changed now. And Mariah didn't confirm this transaction. It holds confirmation from Nakov and no one else. So she confirms. She sends the transaction, send, and now Mariah will sign this transaction by her private key, which stays in this MetaMask. MetaMask holds her key, or a hardware wallet. Also, MetaMask can connect hardware wallet. It can be a proxy to your hardware wallet. It supports Ledger and Trezor, and now it's confirmed. It's still not here because the transaction is not mined. Until it's mined, it's still not confirmed on the chain. This wallet is on-chain and it's public. Everyone can see the transaction requests, who signed when, etc., etc., etc. So if we go back here, we can see that there is another pending transaction. This is the confirmation which comes from Mariah for the payment which I made previously. So submit, it should not be submit transaction, it should be, no, it's not this one. Maybe it didn't refresh correctly. I'm not sure what happens, but after a while, see, the transaction is created by Nakov, it's signed by Mariah, and it's executed. So we can see what happens here. This is the transaction, and this transaction pays this amount. Do you remember? It was 1710 without the 0 at the end. So this contract took from its internal balance, let's say the bank, take from their money and they paid, and this payment was confirmed by Nakov and Mariah. This is how it works. So I wanted to show you what's inside in the code. We can read the code here or maybe here. It's a good idea just to see inside. So it's a multi-sig contract wallet. Once you deploy this contract, you create a multi-signature wallet. For example, I have 2 instances here, 2 different instances. I will open this in separate window. I have 2 wallets here. Something happened with the other. I'm not sure what's exactly. a little bit buggy sometimes, but I have two different wallets, and each of them has different address. So it's like in the object-oriented programming. I have one class, and this class has two instances at different addresses in the memory, right? This is in C#, for example, or in Java class, or in Python class, okay? So when I deploy this contract, which is a kind of class, it will stay somewhere on the chain. It will have address. For example, this address. This is the address of the contract. And in this contract, I have some amount, 7 ethers. These ethers are controlled by the logic inside this contract. If the logic is stupid, someone can take this money, can drain them. If the logic is well written, this will not happen. So what's next? Then what a transaction holds on the chain, it's something like to this address make a payment or contract invocation, send this value, for example 5 ethers, use this data. This data usually encodes operations on smart contracts. For example, if you invoke a function, the function name will be encoded here. Also, the function parameters, input parameters, will also be encoded. And whether it's execute or not to avoid multiple execution. So only wallet, it's a modifier. The modifiers in Solidity are something like checks. Please check this, something like assertion in C++ and Java. C# also have assertions. So it says if the sender of the transaction is the wallet itself, we can go forward. Otherwise, we will not. There are some other things, so I want to show you the creating. In creating, you say Nakov, Mariah, and Steve, these addresses will create 2 of 3 multisig wallets. So this is a kind, when you create the constructor, this is called constructor function, you deploy this, and when is this executed, the output of this is the address on the chain about this wallet. So you can add owner. It looks like everyone can add himself as an owner. It's not true because it's only wallet. But only wallet restricts that this transaction comes from the wallet. And the wallet will send this transaction to itself only exactly when enough signatures are already collected. So if you want to add another wallet, 2 people out of these 3 owners should sign first, and otherwise this will not happen. So remove owner is similar, replace owner is similar, change requirement, again, you can, if the wallet is configured 5 out of 7, you can change it to be 2 out of 7 owners, 2 signatures out of 7 owners by this, but first, these 5 current owners should sign, or 5 out of 7. So each change in the wallet configuration should be confirmed, just like in a company. If the board meets and decides to take a new member in the board, yeah, or to sell piece of the company to someone, he first needs to decide by voting, by confirming, by signing some documents. It's the same here. So submit transaction, what it does, it just adds the transaction internally. It has something like a linked, like a list of transactions inside, and it automatically confirms it. So it does 2 things together. Confirm transaction is what Mariah did a few moments ago. Nakov created the transaction, Mariah read it from the chain. Nakov don't need to send it, the transaction by email, like it works with Bitcoin. The transaction stays on chain. For example, if I export this wallet here, I can just export it. I'm not sure how. There was a way to export wallets. Okay, if I send this to someone of you on your laptop, for example, you can take this and you will see these transactions. But you are not one of the owners, so you will just watch them. So these transactions are public because the Ethereum is public blockchain. It's by design public. It's This is how it works internally. So confirm transaction just confirms something from the list. Everyone with internet access can read what's inside. See, this is the contract. I will put a transaction just to see. For example, I will open this wallet and I will say add a transaction. I want to pay, for example, this amount 7021 to some address, for example, to Peter, and just I will send confirm and will create the transaction. So everyone in internet will be able to see this. See, this is what was done. And if you press read contract, once this is completed, it will take a few moments. You can read, for example, how many transactions are staying here. 7. Okay, give me the last transaction. The last transaction is 6. What's inside? It's confirmed by this person. If I read the previous 5, it also have some, it has these 2 confirmations. So it might be 7 because it was not mine. Yes, see the last transaction, which I created a few moments ago, it's signed only by 1 person. The others were signed by 2 out of 3. Okay, so it's public. And what I wanted to explain you, that confirm is what does this wallet? This is a UI, just to go here. This is a DApp. This is a very good example of DApp. It would be fully DApp if it was published on decentralized storage. Because if this server gnosis.pm falls down, this will disappear. But you can download this code because it's just JavaScript and run it with double click. Or you can pack this code, it's JavaScript, in an app with some JavaScript app builder and install it on your phone. So these are the owners. These are the waiting transactions. We can see the list also here. I'm not sure whether I need to refresh or not. And it also takes time. When I refresh, oh no, this is in the local storage of the browser, and this is on chain. See, it needs some time for this here to refresh because it comes from the Ethereum network, from some node. Okay, so what I wanted to show is just that there is confirm, there is revoke, etc., 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 and there is something that only real experts can understand. This is the external call, which is assembly code. Ethereum supports also coding in assembler, but this is good style of assembler, which is readable, not like in Bitcoin. Bitcoin even doesn't have this. You just put numbers, and that's all. So maybe this is all we have. Another example is 3 out of 5 people. This is broken, but it just takes time. So I created a wallet of these people, and it needed some. I created a transaction which is signed by several people. It's still not executed. You will ask why I have enough confirmation and the transaction is not executed. The reason is that transaction is invalid. It fails during the execution. The problem here was that this wallet had 0 amount and I wanted to pay something, but there were not enough money inside. And so you can see here in the log that the execution was failed. Confirmation, execution, this is mined. I'm not execution failure, see? It's normal. Not all transactions are successful. But there is a difference between mined. This is whether the bank has processed this, and this is whether the payment was really made or not. So I'm not sure whether it was interesting for you, but I will let some time to discuss. You can ask about this topic and also generally about the blockchain, because I'm considered an blockchain expert, so I can answer deep technical questions, or at least we'll try. Some questions? Yes?
Did I get it right that when we are creating a new multi-signature wallet, and it being deployed as one single instance of smart contract into the system?
The question is whether we deployed only one single instance of the wallet. Let me when we create new wallet, when I create here add and create new wallet, this will deploy a new instance of this contract at new address. But one wallet may have many transactions. So, for example, if I and you create together a wallet, it will be one instance. If you and another person and also another person create, it will be different. And one person can take part in different. This is just like I can have a share in different companies. Did this answer your question? Or?
Yes, but this is then also true that all the transactions are being stored inside that one single.
Yes, transactions are inside some of the existing wallets. But only owners, co-owners of this wallet can touch it, can write. Reading is public, and this is general on the blockchain systems. Reading is for everyone, but writing is just for authorized people. Some contracts allow everyone to write, but this is usually not a good idea. Okay, other questions. I'm not sure whether the font is big enough. It's visible. I will try to deploy a wallet. I didn't know why it failed. Other questions?
I'm not sure with the trusts. How does this work? The system which is executing the code of the contract has to be trusted, because we are assigning money to the contract.
Yes.
And
A
rogue system could.
The question is how internally the Ethereum guarantees that this code will be honestly executed. Something like this is your question. Yeah. See, the Ethereum network is decentralized, so it works in a so-called consensus. So there are different nodes. Some of them are honest, some of them are not. So when a new transaction comes, the so-called miners are trying to execute this transaction to take the input from the current state on the chain, which they hold in the memory or in their hard disk, and the transaction changes the state, okay? And the transaction is stored. The state is not stored on the chain. On the chain, we only store the transactions. And if these transactions are processed from the first to the last, the state is recovered. The same principle works with databases. Databases have the so-called transaction log. If you re-execute the transaction log, you will have the same state. So when a new transaction is mined, and the proof of work or proof of stake algorithms proves that this miner have the chance to mine this block, he puts these transactions. It's spread through all the nodes. So, for example, when I execute this transfer, like I did before, my transaction, which I signed here at my laptop, will be sent together with some other transactions into a block. So we can see the blocks here. We have blocks. Each block holds a set of transactions. So this block is sent to all these 30,000 miners or participants. Everyone from them, out of them, re-executes the same logic. And if the result is the same, it's confirmed. And they vote, they say something. So yeah, this passes through the consensus. But it's highly inefficient because you run one piece of code and it's executed 30,000 times. And the result is rejected But this is how it works. So the next version of Ethereum will implement a kind of sharding, which means that these 30,000 nodes will be split into smaller groups, and only smaller groups at some random principle for each block. And these smaller groups will work more efficiently, right? Because less people achieve consensus faster and use less resources. Okay, other questions? Yes?
Well, back the parity multisig wallet was hacked. Can you explain what happened?
Aha, what happened? This is the question is about the hacked multisig wallet. This was the parity multisig hack. It was a bug, this one. It happened in maybe more than a year ago. So hacked again. Yeah, the story was that they fixed it and it was hacked again after the fix. Who hacked this? We have some nickname and some address with the drained money. And library contract was not initialized properly. In fact, the internal details are usually not trivial, like, for example, Linux kernel exploits. But it was not properly initialized thing, which allows to kill the contract without having permissions to do this. Something like, I'm not the owner of this contract, but I'm allowed to delete it from the chain. Something like this. So everything inside this contract was lost. In fact, at this hack, the hacker didn't steal the money, but he just locked them, which is not very smart thing, but it happened.
Was it so badly programmed that he could call the kill method, or did he found some kind of exploit?
There are lots of exploits. For example, the so-called re-entrance exploit, which allows to have a contract execution and to trick the contract to execute itself recursively, and before the transaction is finished and it was written in the state that this person no longer has money, this contract can execute itself and spend the same money several times. But it's complex. The so-called re-entrance attack was very interesting, and there are articles about this. It's about something like this. First, you send some money to the person who wants to. Okay, Peter has money, and Peter calls the contracts, please pay me. He's allowed to do. But first the contract pays, and later he puts that this money are spent. And here they trick the contract to make a recursion and pay again and pay again and pay again. This is called the re-entrance attack. And there are more simple attacks. For example, let's see what will happen if we just skip this. Back in the code. We have this everywhere, but not here. So anyone can add himself as an owner, which is not a good idea. So this is the way it works. These are bugs. Okay, I think we should finish on time. So I will be available around here. So you can talk with me informally if you have to ask me. Okay, or there is no next speaker, but I'm not sure whether we should finish on time or not. I'm not. Is there someone from the organizers? No, okay, please ask. Yeah. Or I will record this and will put it on my blog nakov.com.